All right, today we're going to find somebody's reaction time to see just how quick it is, because some say as you get older that your reaction time goes down. We're going to do a quick little test on the reaction time.
They're way older with 3 times the hair.
It's painted.
No, it's not.
Okay, get ready to catch this thing. So what happens is she's lining up her hand on the zeros, and at some point I'm going to drop it, and she's got to catch it. Okay, that number was 20. It dropped 20 centimeters. We'll do this again. So at some point it's going to drop. Okay, that's 21. Okay, now it's going to happen again. At some point it's going to drop. Oh, she thinks she's pretty quick. 13. We're going to do one more just for fun. Get ready to grab this when it drops, but don't anticipate that. Okay, 15. So that was 20, 21, 13, and 15. Don't forget it. Now check my reaction time here. So you're going to hold it up to here and across the 0, and at some point you're going to drop it. Okay, now that's a 22. Okay. Oops.
Okay. I dropped it.
Yeah, we noticed. Okay. All right, go ahead, drop it. Okay, that's a 24.
Huh?
And that's a 24. Maybe I am getting older. We can use that to find out what your
53.
reaction time is.
You're 53. So
in cat years.
No, in human years.
Okay, so how do you figure out how fast that thing is actually going? I hope this thing is actually recording. So let me show you on a little whiteboard right here.
It is recording, Daddy.
Thanks.
I can see it. See,
Perfect.
it even says. It even says stop recording.
Okay, nice. So what happens is it's dropping, so we can use the displacement of the thing to find out what the reaction time really is.
Okay, I'm gonna leave.
So this, thank you.
Interesting.
Perfect. So this is your number 2 equation on your equation sheet. Well, this is the change in position. I've already done the position minus the initial and all that other stuff. So there's the displacement, the change in position. Now the starting velocity was 0 for everything we did today. So if I want to find my reaction time, or the wee one's reaction time, I'm solving for t. Because I know I'm on planet Earth and I know what the A is, and we found the displacement. Now my average displacement was about 23 centimeters. So be careful. You have to be in meters when you do this, because this is in meters. So solving for the t, I said it's times 2 on both sides. Got it. That's gone. Divide by the a. That's gone. So t squared, that's a t, a little hat on it. And you're going to hold off on your question because I'm busy here. So to find the time, we got to get rid of that pesky square root. So get rid of that thing. So the time is actually equal to the square of 2 times the drop distance, not in centimeters, because this bottom thing, I want to be spot on. So I'm not using 10, I'm using 9.81, which it is here in Kansas. And so the drop distance, the displacement for me was about 0.23 meters. Okay, make sure you're in meters, because that's in meters. You got to be in meters, otherwise they don't cancel out. And 1 over second squared is second squared, but then you just square root, you should get seconds out of that. So if all I do now is find inverse the square, 2 times the 0.23 divided by 9.81 in parentheses equals, whoo, look at that, Daddy is fast, 0.22 seconds. See if you guys can beat that. Yeah, I know the wee one's a little faster, because on average with her 13 and her 15, it's less than 0.23. But for me, hey, that's not bad. Okay, that's what you have to do, is you have to find your reaction time, or if you don't have a stick at home or something with a centimeters or meters on there, or inches at least, you can convert it to meters, then you're going to have to use Daisy's data, which was a 0.13, a 0.15, a 0.22, and a 0.20.
My name's Lil Olsen.
That's right, Lil. Okay, so those are this is Peyton's data.
Lil Olsen. Okay,
and that's what you're going to use. Find the average, and now you find the reaction time of Lil Olsen's. See if she actually. she's going to be faster because I can see it's less on average.
Thank you for coming.
But exactly what is the reaction time? If you have a person in the house who can drop it for you, make sure that person drops it and dropping it for you doesn't let you anticipate it. The key is you can't let the person know when you're letting go of it. Otherwise, you're not finding the reaction time. So you can talk to the person or whatever, but make sure it's the person has no idea, or you have no idea when the person is dropping it. That's how you'd find your actual reaction time. All right. Stopping the share. And stop.